Hello everyone. In today's video, we are going to be figuring out how to name alkynes. So in a previous video, we learned how to name alkenes with the double bonds. Now we're going to be looking at the naming of alkynes with triple bonds. Okay, so for our first compound that we're going to look at, we're going to start off simple. And we will just do the name of a terminal alkyne. Terminal alkyne meaning the alkyne is at the end of a carbon chain. Okay, so when numbering the carbon chain with an alkyne, similarly to that of the alkene, you want to give the triple bond the priority. So for numbering this compound, for naming, we're going to start with number 1 at the terminal alkyne and number through the chain. Okay, since we have 7 carbons in our chain, we know that our base name is going to be hept. Hept being the prefix for a 7 carbon chain. And then our alkyne is at position 1. And just like with the alkenes, we have to say where in the carbon chain our alkyne is. And so we're going to say hept 1 ine. And that denotes that our alkyne is at carbon 1 in a 7 carbon chain. So if we take the same molecule, so we'll take another 7 carbon chain with the terminal alkyne, but now on the opposite end of the molecule, let's add a bromine. So now on one end of the carbon chain we have the alkyne, one end we have a bromine. When numbering the carbon chain for this compound, we are still going to give the priority to the alkyne. The only time that we give the priority to something other than an alkyne or an alkene will be when naming compounds that involve functional groups, such as your carboxylic acids or alcohols. But when we just have regular substituents like bromine, or if we had a regular carbon substituent, the alkyne or the alkene always gets priority. So for this numbering, we will keep the same numbering that we had in the last example. And then we have the bromine. So for this name, again, we have the base hept, and we know the alkyne is at carbon 1. And now we have that bromine that we have to worry about, which is at carbon 7. It's bonded onto this carbon. So we're going to say 7-bromo. 7-bromo hept 1 ine. So we have a bromine at carbon 7 and an alkyne in a 7 carbon chain at carbon 1. Okay. And now let's look at a slightly more complicated example. I'm going to stick with the 7 carbon chain. So let me draw out the alkyne just like we had before. Now we're going to add some carbon substituents to that. So let's add 1 here. Okay, so now taking a look at this molecule, if we go to number our longest carbon chain, our parent chain, giving priority to the alkyne, because again, we only have carbon substituents the alkyne is a higher priority than a carbon substituent. So we're going to start the numbering of our carbon chain on the alkyne. That will be carbon 1, carbon 2, carbon 3. Now if we go down from carbon 3, we have a short chain. We'll end up with only 5 carbons in that chain. So we have to keep going to find our longest chain. And now at carbon 5, we notice whether we go off to the left or we go down from carbon 5, we have the same exact number of carbons. So from here on out, it does not matter which way you number because you will get the same. And we have our 7 carbons. Okay, so if we write out what substituents we have, so I'm just going to make a list of our substituents so that we can keep track. So at carbon 1, we have an alkyne. At carbon 3, we see we have 2 carbons coming off of that. That is our ethyl group. At carbon 5, we see this Y group. Remember, if it looks like a Y with 3 carbons, that's our isopropyl group. And then on carbon 6, we have our methyl group. And of course, our base is hept. So if we try to name this compound, we will write out our base first. And then we already figured out that we have an alkyne at carbon 1. So 1-ine. That takes care of the alkyne. And then we put the last 3 substituents in alphabetical order. So that is going to be 3-ethyl, 5-isopropyl, and 6-methyl. Okay, so our IUPAC name for this compound would be 3-ethyl, 5-isopropyl, 6-methyl, hept 1-ine. Okay, and now I want to take a look at 2 more examples where we have both an alkyne and an alkene in our carbon chain. So to start off, let's look at an example where our alkyne and our alkene are both at the ends of the carbon chain. So let's take a look at this example. So for this example, we have 7 carbons in our chain, and we have an alkyne and an alkene at the opposite ends of the carbon chain. Now, we mentioned previously that alkynes and alkenes get priority over all of the other substituents unless it is a major functional group. But what happens when we have an alkyne and an alkene in the same position on opposite ends of the molecule? When this happens, the alkene is going to take priority over the alkyne. So for numbering this compound, we'll start numbering on the alkene end with carbon 1, and then we'll number through our molecule. So if the alkyne and the alkene start at the same position on opposite ends of the molecule, then the alkene will get priority. Okay, so for naming this molecule, we will have our base name, hept, and then just like the regular alkyne and alkene nomenclature for the naming, we will just combine the two types of nomenclature. And the ene always comes before the ein because of alphabetical order, en versus yne. So here we will get hept 1, 1 ene to show that our alkene is at carbon 1. Notice we did not write out the full ene. That's because now we're treating the alkene as the first substituent. So instead, we will just leave it en. And then we write the position of the alkyne, which going through the carbon chain starts on carbon 6 and goes to carbon 7. So we'll start with carbon 6. And then we write our ein. So when an alkene and an alkyne are present, we have the hept 1N6 ein. You can also call it an ene-ein, indicating that there is both an alkene and an alkyne in the molecule. Okay, so with that, let's look at the opposite example. So now we have an alkyne and an alkene. But now let's say they're not in the same position. In this case, you go with whichever type of bond comes first. So if we number from the left side of the molecule, we'll get our alkene starting on carbon 3. But if we number from the right side of the molecule, alkyne would be on carbon 1. So we're going to prioritize the alkyne because it comes first in the carbon chain when we number it from that direction. So we will number from the alkyne and number through our molecule. So now we have 9 carbons in our base chain. For that, our base is going to be non. And then we have, again, alkenes always come before alkynes in the nomenclature because of alphabetical order. So our alkene starts on carbon 6. And then we write our alkyne, starting at carbon 1. Okay, so now we have our name. However, when we think back to the video on naming alkenes, when we have different groups on both ends of the alkenes, we have to indicate whether the alkene is in the E or the Z form. And so we will have to indicate that in the name, even when other groups are present and it's not solely an alkene. So if we take a look at our alkene, we can say we have an H, these implied hydrogens. And then if we look at our groups, we can see that our biggest group here on the left side of the alkene is on top, priority 1, and then the hydrogen is on bottom. And then for the other side of the molecule, priority 2 is on top and priority 1 is on bottom. So again, looking down the double bond, we see that the priorities are on opposite sides of the molecule. So priority 1 on the left-hand side is on the top, and priority 1 on the right-hand side is on the bottom. So we get our E form of the molecule. So we have to indicate that in the name by putting E in parentheses in front of the name, indicating that that alkene is the E form. Okay, so there is a quick video on how to name basic alkynes and then alkynes that also have alkenes present. And then the next naming video that will be coming out will be looking at the addition of functional groups onto compounds with alkynes and alkenes present. So we're going to take naming one step higher as far as the complication of the naming. However, now that you have all of the fundamentals of alkyne and alkene naming, when we add functional groups, it will not be quite as bad as it seems.